Hello, my name is Anubhav and I'm Technical Marketing Engineer working for Security Business Group at Cisco Systems. In this video, I will talk about Cisco ASAv Scalable design using Azure Internal Load Balancer with HA ports. Before I talk about design, let me step back and talk to you about Azure ILB with HA port. This is a new load balancer which will give you functionality of forwarding or load balancing all port traffic to your VMs or network virtual appliances. This load balancer is currently in preview mode. You can sign up for this preview, and this is currently available in regions mentioned in the slide. Now, before I talk about this design, let me discuss about use cases. If your requirement today is under 1 gig and availability is not a problem, then only one Cisco ASA appliance is a good solution for you. But if you are looking for availability of your applications, and if you are looking for scalable design, so that if there is requirement for more throughput in future, you can scale out. In that particular situation, you can utilize this design wherein you can place multiple firewalls behind a load balancer and let the load balancer forward traffic to firewalls. And on firewalls, you will apply your security policies, your NATing, your stateful packet inspection, and forward traffic to destination VM. So in this example, we leverage UDRs. UDRs are user-defined routes, which takes precedence over any other routes in Azure environment. And we also leverage internal load balancer. This is a different kind of load balancer available, which can forward all port traffic to NVA. NVA is Network Virtual Appliance. In this case, ASAv. Now, if you look at this example, I have created 3 subnets. First subnet is inside subnet, then I have outside subnet. In addition to this, I also have NVA1 subnet. I have created all ASAs in NVA1 subnet, and my internal load balancer is also part of NVA1 subnet. If traffic is initiated from inside for VM located in outside subnet, traffic will hit inside UDR. Inside UDR will forward that traffic to ILB because of the route given in inside UDR. Now, when ILB will receive the traffic, ILB would calculate hash of that traffic based on source IP, destination IP, source port, destination port, and protocol. 5-tuple load balancing would happen. It will pick up one ASA from the backend pool, and it will forward that traffic to that ASA. Now on ASA, we apply security policy, and if traffic is allowed, it is here pinned back to the same interface, but it is forwarded to first IP address of NVA subnet, which is the default gateway assigned to ASA. And this default gateway is assigned at the time of installation of ASA or deployment of ASA, and it is assigned dynamically by DHCP. This first IP address is Azure native fabric, and that native fabric knows how to reach destination subnet. Azure native fabric will forward that traffic to destination machine, and destination machine is located on the outside subnet. Now when reply will come back, it will hit UDR, outside UDR, and based on the route given in outside UDR, traffic will again land up on ILB. Now ILB is designed in such a way that it will go ahead and forward traffic back to the same ASA from where initial packet was seen. So whenever there is a reply, it will look for the same ASA. So that is their design architecture. So using this design, you can scale up to 1000 ASAVs. That is the theoretical limit. But in this example, we have shown you 3 ASAs, but as and when a requirement for more throughput is there, you need to just provision another ASA with same configuration and put it in the backend pool of ILB. Now ILB is also responsible for keeping check of health of the ASA. If ASA is not available, it is removed out of the backend pool immediately. There is another kind of deployment when you have ExpressRoute connectivity. Now in case of ExpressRoute connectivity, you can apply UDR on your gateway subnet, and for inside subnet make ILB as next hop. On the other hand, on an inside UDR for add a route for your data center network and make ILB as your next hop. So using this, whenever any traffic is initiated from data center towards your inside network in Azure, that traffic will come to your virtual network gateway, then gateway UDR is applied, it is forwarded to ILB. ILB will then forward it to one of the ASAs available in the backend pool, and ASA will inspect that traffic, filter it, and if traffic is allowed, it will forward the traffic to the destination machine by sending it to .1. And when reply is received, it is again forwarded to ILB. ILB will again look at the hash and it will forward it to the same ASA, and symmetry is maintained. So using this design, you can scale out your network, and I will just show you step-by-step deployment of each component that I've talked about in the previous slide. So I'll just pause this video for now, and I will log into portal.azure.com and I will show you step-by-step deployment of the entire network. Welcome back. I'm now logged into portal.azure.com. In step 1, I will go ahead and create a resource group. Now I'll go inside this resource group and I will add virtual subnets. I'll create a virtual subnet and associate that virtual subnet to this resource group. So I'll just click add here. .82.00/16. I'll put it in the existing resource group which I created in last step. Default network I'll give outside, and I'll use 10.82.00/24 for outside subnet. I'll just create it. So once this VNet is created, I will create subnets inside it. So I need outside subnet, which is already created when this VNet is deployed. I will then create inside subnet. Along with that, I will create 4 NVA subnets. I will tell you why I will create 4 NVA subnets. But let's begin with our first subnet. Inside NVA1, this is going to be the subnet where I will have all my ASAs and my ILB deployed. So I'll just go ahead and use NBA 1. I need NBA 2, 3 and 4 because ASA requires at least 4 subnets or interfaces to get deployed. So I'll be using NBA 2, NBA 3, NBA 4. So now I have required subnets already created. So again, outside subnet is the subnet where I will place first endpoint. Inside subnet is the subnet where I will place second endpoint for testing, and I will place ILB and all ASAs in NBA 1 subnet. Now next step is to create ASA. So I'll click plus sign here and I will look for Cisco. From all the offerings, I need to select Cisco ASAv BYOL4 NIC. I'll click create. And I will create new resource group. Because deployment of ASA requires a new resource group or existing resource group which is empty, there is nothing. So what I'll do is I'll create new resource group for ASA and I will use existing VNet. So I'll just use default standard D3v2 instance. I'll create a storage type as well. I'll just create a storage account for this device. I'll give this device a public IP address for management purpose, but later on I can disable that as well once I have end-to-end connectivity, or if there is ExpressRoute I can use private address as well. So I'll just give this device public IP. I'll go with static IP for now. Now I'll select my VNet. So I'll just select my VNet which I've created. Now I'll select subnets. First subnet I'll give is NBA 1, NBA 2, NBA 3, NBA 4. I'll click OK. I'll click OK again. This is running some validation in the background. Now I'll click OK. Let me hit purchase again. Okay, now deployment started. Similarly, I will deploy 2 more ASAs and each ASA will go in its own resource group, but it will use existing VNet. So I'll just pause this video, deploy another 3 another 2 ASAs, and then I will resume. Welcome back. I have now deployed all 3 ASAs and I have resource group. So I'll quickly show you design that we have now. So these new ASAs came up with IP address 2.4, 2.5 and 2.6. Now next step is to deploy this ILB. So I'll quickly go back to portal and click new icon, and I will type load balancer. I'll just give it a name. Internal load balancer, and I'll go with standard, which is a preview version. I'll select my virtual network and I will put it in NVA1, and I'll give it a static IP address 10.82.2.100, and I will put it in existing resource group, which is my resource group that I've created for this setup. I'll just validate it and click submit. So now I have all the 3 ASAs deployed, and now I have my load balancer also deployed. While these devices are coming up, let me go ahead and put test machine. I'll go with a Linux machine. And I'll put it in existing resource group. Next. I'll go with D1 size, smallest one here, and in other settings I will select my existing network, and I'll just go ahead and put it in the internal network. I will leave other options as same. Boot diagnostics I will just disable. I don't need high availability for this server, so this is my workload that is going to be in internal subnet or inside subnet. Similarly, I will create another VM for outside subnet. I will use existing resource group, and I'll hit slave, smallest instance. I will put it in same VNet, but this time I'm going to put it in public IP. This is the security group. I'm sorry, I was looking at the wrong page. So it is going to the same VNet, and it is going in the outside subnet. I'll disable boot diagnostics. I'll click OK, and I'll go ahead and hit purchase. So now these two servers are getting deployed. In the meantime, let me go to my load balancer, and in the load balancer I will create probe. I will add probe ASA. I'll use TCP 22. So this load balancer will probe all ASAs using port 22 protocol SSH, and once this probe is done, I will go inside and create backend pool. Welcome back. Now probe is created and we can now monitor ASAs on port 22. Now before we move into next step, let me go ahead and tell you something which is really important. If you go to backend pools and if you try to add new device in the backend pool, you will not see your ASAs here. Reason is your ASAs are deployed with public IP address. Until the time you have public address on ASA, it won't be added in the ILB. So what you can do is you can access your ASAs. You can add these commands on all the ASAs. This command is used for providing SSH or allowing SSH connection coming from this. This is the load balancer probe address. So we need to allow this. Second, this command is required for enabling hairpinning on the interface, and this is an optional command to allow ICMP traffic. We will rename interface management 0/0. We'll name it as NVA1, and the other commands are optional commands, and if you want to enable license, you can enable these. So as a part of this demo, I won't be enabling license, but what I'll do is I'll just skip these steps for now and disable IPs on my ASA so that I can add all ASAs in the backend pool. So I'll go to each ASA one by one and disable public address from there. In order to disable public address, we need to go inside that ASA, click NIC 0 and go to IP configuration, go to this page and just disable address, public address. Similarly, I'll do it for ASA2 and ASA3. Welcome back. So all IPs are now saved, so we don't have public address on any of the ASAs now. I'll go back to backend pool. I'll click add. ASA pool. I'll select my VNet. ASA1, I'll select first interface. ASA2, I'll select first interface. ASA3, I'll select first interface, and I will click add. So this will again take 1 to 2 minutes to add all ASAs in the backend pool, and I will now pause this video again and come back when all the ASAs are added in the backend pool. Now you can see that we have all ASAs added in the backend pool. Next step is to create load balancing rule. So I'll just click add LB rule, and make sure that to click HA port, because once you will click HA port, it will forward all traffic instead of just port based traffic. If you enable this feature, it will forward all traffic to your VMs. I will select ASA pool in the backend pool. Probes, I'll be using port 22. I'll leave other settings as default and I will click OK. Now this will take a couple of minutes again. In the meantime, I'll show you my diagram. So I deployed this machine in the internal network, and it got IP address 1082.1.4, and other machine was deployed in outside network and it got 1082.0.4. I have 2.100 as ILB address, 2.4 is first ASA, 2.5 is second ASA, and 2.6 is third ASA. So now I'll just go back to load balancer. I have everything set up now. I need to just log into my boxes and log into ASAs first and add these commands in each ASA so that I can enable ICMP traffic, and then I will forward ping from internal machine to external machine and vice versa, and we'll see how traffic is getting forwarded between the three ASAs. I'll go ahead and pause this video and log into all the boxes and I'll resume again. Welcome back. I'm now connected to all the boxes. I'll just show you IPs on all ASAs. This is first ASA, second ASA, third ASA, and I have access to internal host as well as external host. I added these commands on all the ASAs just for this demo. I have added permit IP any, but you can control your policies and allow access accordingly. Now next step is to get back to portal.azure, and here we need to create UDRs. So I'll just click here, type route table. I need to add two route tables. First let's start with inside route table. I'll just name it as inside dash UDR. I'll put it in existing setup. I'll create another UDR, and these UDRs will force traffic to ILB. Now I'll add another UDR, which is going to be outside dash UDR. I'll put it in the same resource group. I will now go back to dashboard and go to my resource group, main resource group. In this resource group, I'll see those two route tables. So I'll start off with inside UDR. So this is inside UDR subnet. In inside UDR, I will first of all go ahead and add a route. Outside network, and outside is 10.82.0.0/24, and I'll point it to virtual appliance. I'll forward it to 10.82.2.100, which is VIP of our ILB. I've added this route, and I will associate this UDR to inside subnet. So any traffic initiating from inside subnet going to outside subnet, next hop will always be VIP of ILB. .100. Now I'll go back to my resource group again. I'll look at UDR outside. I'll add a route for inside subnet, inside network 22.1.0/24 virtual appliance 10.82.2.100, again VIP of ILB. I'll associate this UDR with outside subnet. So now if we look at this setup, now we have our endpoints. Both endpoints are accessible. From jump box, I have access to all the ASAs, and I have these two UDRs created. Now let me pause this video and log into jump box again and initiate our testing. Welcome back. I'm now back in jump box. I'll show you IP. This is first ASA, second ASA, third ASA. I have a debug ICMP enabled on all the boxes. I'll just initiate ping. Now you can see that traffic is getting through firewall. So using this particular mechanism, we are able to stitch multiple firewalls in transit, and at the same time we can have active forwarding when traffic is of different type. Right now I'm using second firewall for forwarding traffic. If I'll initiate another kind of traffic, that can take firewall 1 or firewall 2. So in this video I tried to show how we can use ILB with HA port to scale out our solution, and we leverage a lot of native Azure components as well, like ILB, UDR, and on ASA side we have same security traffic, intra interface command to hairpin traffic. I hope you enjoyed this video, and thank you for watching.